Hello students, in this class we will try to understand what are the different data types available in Java and how to use that. The data types are very similar to what we have experienced in C and C++ but with increased range. Let's first try to understand why do we need these data types and what is the necessity to have different categories of data types. So for example, let's say we have a guest at our home and now the task is to serve the guest a glass of water. So what do we do? At this point, we serve the water in a glass because that's the suitable carrier for the water. Now imagine this funny situation where to serve the water, if we serve the same amount of water in a bucket, how awkward it will be. So what do we need to understand here is that depending upon the amount of data to be carried or used, the similar thing should be our carrier, that is our data type. So basically the data type defines the range or type of data it defines. For example, let's look at this image which we are seeing at the screen. We have got byte. We have got byte which is of 1 byte, short 2 bytes, 4 bytes, 8 bytes and so on. So we know that 1 byte is smaller, boolean is 1 bit, the smallest, and then we have got the short which is of 2 bytes. What's the difference between 1 byte and 2 byte? 1 byte means it can carry information up to 8 bits. Short means it can carry information up to 16 bits. So there may be some situations where our calculation or our task or the values which we are going to use in this present program may only range from negative 128 to positive 127. At that point of time, suitable data type to be used is a byte. Suppose now I want a bigger number. Suppose my calculation or intermediate calculations may range or they may cross more than 1 lakh, 2 lakh, 10 lakh and so on. If you want some bigger numbers, so we have got this integer as 4 bytes. Suppose if you are very interested in precision, so if I'm interested in fractional numbers, so I may go for float, double and so on. So for example here long is ranging from 8 bits. So if we can just read out this number, it's so difficult, even difficult to read out this number. This itself says how long a long numbers can be. So basically what a data type says, it defines the kind of value which we can store and it defines the range of value which we can use. So as I said in the guest example, so it will be very awkward to carry the water in a bucket and serve the water to the guest in a bucket. See, you're serving the purpose there. That means you had to serve them water. You're doing it in a bucket. But always we have to be very appropriate in the situation. Now talking about being appropriate in a situation, while writing a program, a good program is that program which is memory efficient and time efficient. If we simply use integers where a byte can do the job, then we are simply wasting the memory. See, just for the explanation purpose or the demonstration purpose, we can go for a byte or a integer and so on. But this will really matter when we are designing big softwares or complex software which needs to respond to you in real-time constraints. So let's see some of the examples based upon these different kinds of data types. For example, we have always been using NetBeans IDE, so I'll just walk you through some basic Java programs. So I'll start with a bool. So this example is going to demonstrate how a boolean data type is used. So this boolean data type is a new data type which can store only two different kinds of values. So as shown in this image, so we have got bool at the bottom here. So boolean says it's of 1 bit. It stores either true or false. Okay. So it's going to literally store these characters, my dear friends. TRUE. Any variable of type bool can store TRUE. Hello friends. Now we are going to see another example of data type, that is on a byte. So now let's have a look at what exactly is this byte again. A byte size is 1 byte and it stores whole numbers from -128 to +127. This means if you are doing such a kind of a calculation or such a kind of a process where the values may not cross -128 to +127, then we can go for this byte. So this is, let's see one example for this byte. So line number 21 declares a byte variable a with the value 126. Now line number 24 prints the value of a, that is we should get 126. Now value of a is incremented. That is a simple to show you that as we use our basic mathematical operations on integer and float, we can use the arithmetic expressions, simple increment operation on this a2. So now this 126 should be incremented to 127 here. And now in the line number 31, this is the second time this a is incremented. That is, the maximum value of this byte is once again 127, but now in the line number 31 the value of a is to be incremented to 128, but it crosses its range. So now it will go circular wise and it will once again carry out the buffer overflow value. So this value is showed in line number 32, that is a, and once again the overflow value will be showed in line number 36. So now let's run this file. Line number 126 shows, line number 24 outputs the value 126, and then line number 26 increments a, so we get the value 127, and then in line number 31 we increment it further. That means we expect it to reach 128, but the byte ranges crosses, so this goes circular wise and then it once again starts from -128 and then it goes for -127 and so on. So some complement operation is also involved here, but that is the beyond the scope of this particular explanation. So here this example explains you how to use a simple byte in Java. So now let's look at another example. So let's look at the character. So here in this example we are looking at the character. So now once again let's look at what exactly is the size of the char. Char is of 2 bytes, my dear friends, and it can store a single character or letter or ASCII values. It can store a single character or letter or ASCII values. Character or letter, it depends upon the terminology we use, or the ASCII values. Okay, so ASCII values, so we all are aware of ASCII values. ASCII is nothing but American Standard Code for Information Interchange. So every character we find on the keyboard has got a specific whole number associated with it for the information interchange during the computer operations. So now let's look at a simple example on that. Here in the line number 14 we have got 2 declaration of character variables. So once again it's character variables ch1 and ch2. ch1 another character, one character variable, ch2 another character variable. That means these two are having 2 different blocks in the memory. Line number 15 associates 88 with ch1. So as we saw in this image, either the character can store the letter or the character we find on the keyboard, or it can store its ASCII value. So now 88 is the ASCII value for X. Okay, ch2 now actually stores a character Y. Now when I print ch1 and ch2, Basically, when this println prints ch1 and ch2, the output is expected to be in the character or in the letter format. So now let's look at the example. So I have run this particular file, and now the output says ch1 and ch2 followed by x and y. So now, as you can see in the line number 17, it is not println, it is just a print. So after printing ch1 and ch2, the cursor shall be blinking in the same line. So the output of this line will be appended to this particular 17th line's output. So after displaying ch1 and ch2, the first value to be displayed is ch1. So what is stored in ch1 in the line number 14? We can see that in line number 15 we can see that 88 is stored in ch1. That is, 88 is the ASCII code for x. So here in the place of ch1 I can see x being displayed in the output. In line number 16, the character y is stored in ch2 and character y will be displayed using the variable ch2. Now a simple blank space is appended with this ch2. So that's why I can say that ch1 and ch2 colon followed by x space y. So this is the output of this particular file. So this is a simple example which shows the usage of the character variables. Now let's look at another example. Now let's have another example of char, and of course now we are having a increment operation here, very simple one. So this is the second example of character, where, my dear friends, in the line number 13 we have a character variable declaration. In line number 14 we are assigning the character x to ch1. Now system.out.println ch1 contains what? ch1, that is x. Now in line number 16 ch1 is incremented. So as you know that the representation of x can be in terms of its ASCII value too. So when ch1 is incremented, it actually tries to show you the next value, that is 89, that is the character y. So now let's look at the output of the same. ch1 contains x. ch1 contains x is the output of line number 15 here, and in line number 16 we are incrementing ch1, that is the 88 is incremented to 89. Now line number 17 displays ch1 is now y. This is how we can have a basic increment operation on the character variables. So these are usually included in aptitude test conducted in the recruitment process. So this is what happens when you increment a character variable. Now let's go to another example. Now let's get into integer. So these are going to be very basic explanations compared to what we have already experienced in C and C++. Using integers we have done stacks, queues, linked list, and so many other things, but since this is the beginning of Java, we have to go through this one. Now this is a simple example of integer. So now let's have a brief look on what exactly is an integer. In Java, any number which falls within the range of -2147483, oh my god, such a big number, to +2147483,647 is called as an integer, and of course it has to be a whole number. Fine. Now in the line number 14 we have an integer variable declaration mynum, and we are initializing it to this is 1 lakh. So now mynum holds the value 1 lakh. Now in the line number 15 we are printing the same. So now when I run this, so I should get the output just 1 lakh. So now let's see this one. Yes, so now the output is 1 lakh. So this is how we use a simple integer in Java. Now let's look at the short. What is short? So now Java clearly defines what is the range of each and every data type. So now if I want to use a whole number but not a very bigger one, Now suppose we have the shorts range from negative 30,768 to positive 30,767. Remember, my dear friends, this was the integers range in C. So we have learned that 32,768 to 32,767 is the range of integer in C language. Now as the languages evolved, even the data types also evolved. So here we have a deeper categorization of the different data types. So here short means it is a data type which can be 2 bytes long. So when it is 2 bytes long, of course it can carry the values from negative 32768 to positive 32767. This only means this thing, my dear friends, if my mathematical calculation does not cross 30,767, then instead of simply wasting the memory, we can use this short variable. In this example, in the line number 17, I have declared my num as one integer variable, one short variable, which carries the value 5000. Now in the line number 17, we have this declaration. In the line number 18, I am printing the same, so the only line of output should be 5000. So this is the output. The only line of output is 5000. So now let's do some experiment here, my dear friends. So now let me just try to show you what will happen if I cross the range. So now the same my num. Now I will, instead of storing 5000, let me try to hold a 50,000 here. Now this is the beauty of integrated development environments, my dear friends. We need not wait for syntactical errors till we compile the code. So this is how we can assess the situation here. So see here, these are referred to as balloons, my dear friends. So we have got a balloon here automatically, because here the IDE has automatically run the program for the errors, and it says possible loss of precision. So I want you to look at the flag here. So it says possible loss of precision, required short found integer. That means in the line number 16, we have declared a variable mynum as short. That means Java knows, this Windows operating system on which we have installed this JDK. This JDK knows that the range of this particular mynum variable must not cross 32,767. As and when I assign this value 50,000, which well exceeds that 30,767, automatically it is showing me the error. Unlike our traditional editors, what we have used in C and C++, like we have used developer C++, we have used Turbo C, there we don't have this option. As and when we do syntactical errors, we don't get the error messages there. So here, line number 19, I am trying to assign 50,000, but this ID is not allowing me to do it. So this is one more beautiful way where our program can be scanned for errors, and we need not wait for the entire system to crash because of these kinds of errors. This is one example of short, my dear friends. Now let's look at another example. Let's go to float. Now let's come to this image. What is a float? So when we say float, we think of precision. Suppose if I want to calculate average of 3 marks. Average of 3 marks may not always be a whole number, my dear friends. So it may have fractional numbers. The average may be 87.5, 65.5. That 0.5 value, how to store that one? If I use byte, short, int, long, as you know, these will fall under whole numbers. If my calculation needs only whole numbers to be dealt with, then all these will come into the picture. But right now I am very interested in precision. Then I should go for either this float or double, and we have got some minor adjustments here. We'll see what exactly is that. My dear friends, here by default any fractional value in Java is treated as double. because Java don't want you to lose that precision. So automatically, even if you declare something as float, it will take it as a double until and unless, my dear friends, I want you to concentrate here in line number 14, where I have declared my num variable but with the assignment of 5.75f. My dear friends, here f in the line number 14 says that this 5.75 must be treated as a float instead of a double. So here double, automatically the size becomes 8 bytes and sufficient for storing 15 decimal digits. Now float can store values up to 4 bytes, that is up to 6 to 7 decimal digits. Now I am forcing the Java to treat this 5.75 as float. Now before explaining it further, let me just finish its execution. So now I am trying to run this file, my dear friends. So now I am getting this value as 5.75. So the line number 15 displays the value my num, and the my num holds 5.75 right now with the suppressed value f. So now let me just remove this f, my dear friends. So now what does it say? It says possible loss of precision. Concentrate here. These flags, these balloons give a lot of meaning, which can really fine-tune your experience with Java. So now let's read out what this flag says. It says possible loss of precision, required float found double. Once again, concentrate, my dear friends, here. It says required float but found double. As per our C and C++ knowledge, look at the line number 14. Line number 14 says, in the line number 14 at the right hand side I have 5.75. With the basis of C and C++, 5.75 is a legitimate float value according to C and C++. But Java, once you say 5.75, automatically it's going to take it as double. This means here the my num must have been of type double. So now let me just change it to double, my dear friends, and whoosh, and now we don't have that error now. So by default every fractional value is taken as a float, double. But if you want any fractional value to be taken as a float, then you need to append a f. This f forces the Java to restrict its precision value from having the 15 decimal digits to up to either 6 to 7 decimal digits. So now this is how some kind of fine tuning we have to do in our own coding style. So f refers to the number being float in our program. So now let me rerun this particular code. So once again this is 5.75. Okay, now let's go to another example here. So we have got plenty of them. Long, so let me just have this long. Long is very long, my dear friends, very long. So what is this long? Once again, it is a very big carrier for our whole numbers, bigger than integer. Integer can store up to 4 bytes, but long can have up to 8 bytes. So now one important thing what you can notice here, the character L, my dear friends. So it says long my num, and it is some very big number. Let me just count how many numbers, how many digits do I have. 1 2 3 4 5 6 7 8 9 10 11. So it is approximately 1500 crores or some other number like that. So now let me just print this particular number using line number 15. Line number 15 is expected to print that particular number. So now let's see the output. It says the same number reiterated again. So now let's experiment it, my dear friends. So let me just remove this L. So now what does it says? Every time while doing the programming in IDE, my dear friends, in IDE, integrated development environment, whether it is going to be NetBeans or Eclipse or IntelliJ or whatever you want to use, even in the Android Studio, These IDE are built to make the user experience very friendly. So we have to understand the balloons, we have to understand the flagged values there. So it says integer number too large. So why does it say so? By default in Java, every whole number is treated as an integer value. So here this value, that is 1500 crores, crosses the range of the integer. So now here the range of this integer is this thing, -2147,483 and all those things, all those numbers. Since I'm not appending this L here, this is treated as an integer value. So now once I append it as L, this will be treated as a long number, and then it will show me the expected output. Now we can see how this Java has changed the programming. For float I need to append F, for long I need to append L. So while we are beginning with the Java programs, my dear friends, we need not experience all these big numbers, because we are trying to learn. We will be experimenting with the different values, variables. For experiment 6 it may not vary, it may not mean much for us, but all these things we do to build our career. We write softwares, we want to reach a position where we are going to be a part of a developing team. There this kind of precision programming is very necessary. So that's why it is very important to know what are the fine tunings we have in our Java. So now let's have another example. We will try to learn what exactly is double. So now where does this double fall in the data types category? Double is of 8 bytes and it should be used to store fractional numbers, sufficient to storing 15 decimal digits. This means after the dot we can have up to 15 decimal digits as the precise value. Now let's look at how we can use this double. So this mynum is the variable of type double. So now I'm going to prefix or suffix this D with 19.99. So now let's look at this answer here, my dear friends. I have given Shift F6. Shift F6 is used to run this current file which we are seeing in front of us. So we have taken double mynum D. So now let me just remove this D. Do we see any change in the behavior of IDE? It doesn't, because the D what we had earlier itself means that it's going to be double, and also Java treats every fractional number as double. It is helping us actually, because it don't want us to lose that precision. So that's why this Java is going to be very user friendly. So it avoids, it prompts, it forces us to not to make mistakes. So once we have crossed a stage where we don't have any red balloons, then it means we are okay with it. But still we have a balloon here. So now let's see what exactly it says. It exactly means that we should have appended D. It is not mandatory, my dear friends, but appending these necessary characters will only beautify our program. So now let me other program left in this particular package. I have not explained package data types. I feel this is little too early to explain what exactly is this, but still you all are capable. But I will hold it for this class. So I hope I have come across every other thing. Okay, we have got another silly example here. Okay, so now let's see what exactly is this. This is a simple experiment where we have got double variables. So once again I will not hesitate to show you this image. What is a double here, my dear friends? Once again, this double means of it is used to store the fractional numbers, and it can store the precision. It can give us the precision up to 15 decimal digits. So up to 15 decimal digits, my dear friends. So here in the line number 13 I have got pi, r and a. So I hope this program is going to show me or calculate me the area of circle. Okay, radius, it takes the value 10.8. Mind it, my dear friends. So here I am not appending any D or F. Okay, so I want it to be double, no issues at all. Pi carries the value 3.1416, our standard value since our school days. Area gets the value of pi r square. So this 3.1416 multiplied with 10.8 into 10.8. So now let's look at the answer. So let me just save the file, and this is the area of circle, 366 point some precision value. So this is a simple example of what exactly or how exactly the data types are used in Java. So this is a simple example of set of series of data types what we find in Java. In the next video, so I'll come back with different operators which I have already lined up here, and post operators we will see the control statements, very simple, and then we will see the usage of variables. So this is going to be very easy, my dear friends, but it is very lengthy to give a vast feeling of what all we can do within the Java. So I'll end my class here. Hope we'll meet again in the next video. Thank you.